Good evening. Today we're going to discuss the types of elements on the periodic table. The periodic table has three different types of elements on it. You'll see here they're shaded in somewhat different colors. You have the metals in blue, which make up the left-hand side of the periodic table. I've circled them in red here. Metals make up most of the elements on the periodic table. All of these metals, shaded in blue, share similarities which we will discuss in a moment. The lone exception to the rule is this element here, the element hydrogen. Hydrogen is a non-metal, but because it only has one electron in its outermost shell, it sometimes acts like an alkali metal here in group 1. It has a very similar valence structure, meaning it only has one electron in its outermost shell, just like all of the metals here in group 1. But because of its electron structure and the fact that it only needs one more electron to fill its outermost shell, hydrogen also acts like the nonmetals in the halogens group because they only need one electron to fill their outermost shell. Well, same holds true for hydrogen because the first shell, remember the K shell, only can hold 2 electrons and hydrogen has one, so it only needs one more to fill its outermost shell, just like all the elements in the halogen group. It also shares many of the traits of a nonmetal, which we will discuss in a moment. On the right-hand side of the table, and including hydrogen from the left, we have the nonmetals. The nonmetals here are shaded in green, and I have also circled them in green. Notice I've also included hydrogen because hydrogen is a nonmetal based on its traits. These all share similar traits to each other. In the middle, separating the nonmetals from the metals, we have the metalloids. The metalloids form this staircase-like structure. This staircase separates the metals from the nonmetals. Metalloids actually share traits with both metals and nonmetals. Now let's take a look at each section of the periodic table and break it down, starting with the metals on the left, and let's look at their traits. On the left-hand side of the periodic table, as we stated, we have the metals. Most elements on the periodic table are metals, and they all share similar traits. In the middle of the periodic table, separating the metals from the nonmetals, like we said, we have the metalloids. The metalloids have some traits that are like metals and some traits that are like nonmetals, and it forms this staircase-like structure. There are only 7 of them that we are going to look at this year. And finally, on the right-hand side of the periodic table, and including hydrogen, we have the nonmetals. And the nonmetals have traits that are very much different from the metals, but they share some traits with metalloids. You may also notice that they are not as numerous as the metals. Now let's go over the different traits of each type of element. Let's first look at the metals here. Metals are good conductors of heat and electricity. They are what we call malleable, which means they can be hammered into flat sheets of metal and shaped to form fenders on cars or turned into an aluminum soda can. One way I remember that malleable means hammered into flat sheets of metal is that a mallet is a type of hammer. Metals are also ductile, which means they can be pulled into long wires. They have luster, which is a synonym for shiny. It just means that they're shiny. They have high melting points. And some metals during a chemical reaction like to give up or lose electrons, and they form positive ions. Let's look at the traits of metalloids. Remember we said there are 7 of them that we're going to look at this year. So these 7 metalloids forming the staircase in between the metals and the nonmetals. Now, metalloids are unique because they are better conductors of heat and electricity than the nonmetals, but not as good conductors of heat and electricity as the metals. Metalloids are also malleable and ductile. Some are shiny, which means they have luster, and some are not shiny, which means they are dull. And they are all solid at room temperature. Metalloids are very unique because under certain conditions, they become good conductors of electricity, which makes them very useful because they are used in the production of semiconductors, which are used inside computers. And finally, let's quickly look at the traits of the nonmetals. Nonmetals are poor conductors of heat and electricity, which makes them very good insulators because they prevent heat and electricity from traveling through them. So many times you'll find nonmetals contained in things like coolers or wrapping electrical wire so that that heat and electricity does not get lost into the environment and it can be transmitted as efficiently as possible. Nonmetals are brittle, so instead of hammering them into sheets like a metal, if you hit a nonmetal with a hammer, it'll shatter and break if it is in its solid state. They are not ductile, so they cannot be pulled into wire because they are brittle. They are dull, which means they lack luster. They do not have any luster. And during chemical reactions, they gain electrons, forming negative ions, meaning they pick up those electrons and they become more negative. So you see that nonmetals and metals are almost opposite in most of their traits. One of the most interesting points of metals and nonmetals is the fact that metals lose electrons, and those electrons are lost to nonmetals. So as metals become less negative, forming positive ions, nonmetals become more negative, forming negative ions. And you'll find when we get into chemical reactions that ionic compounds are formed when a metal gives up an electron to a nonmetal. That's all we have for today. Hopefully this was quick and you understand everything. If you have any questions, please feel free to ask as we walk about the room. Have a great night. See you tomorrow.